Namaskar, students. Let us discuss Poisson distribution. In 1837, French mathematician Simon de Poisson has introduced Poisson distribution as an limiting form of binomial distribution. So you can say that Poisson distribution is coming from binomial distribution. In binomial distribution, if n is very large, n is number of trials, or it is infinite, the use of binomial distribution is not logical. So in this type of cases, we can use Poisson distribution as an limiting form of binomial distribution. In binomial distribution, if n is tends to infinity and probability of success p is very small, then you can say that binomial distribution becomes Poisson distribution. In Poisson distribution, average number of success NP is a finite number. NP is equal to m, or sometimes it is denoted by lambda. This is the probability function of Poisson distribution. That means using this formula, you can calculate various probabilities. Probability function is Px equal to e raised to minus m raised to x upon x factorial. So this is the probability function of binomial distribution. Here x is from 0, 1, 2 up to infinite. E is a constant known as Napier's constant 2.7183, and m equal to n into p. N is number of trials, P is probability of success. So this is also called mean of the Poisson distribution. The list of different value of Px and different x is called Poisson probability distribution. Which are the properties? So obviously x is from 0, 1, 2, 3, 4, 5, 6, so on. So this is a discrete distribution. Number of success x is a variable for Poisson distribution which takes values from 0 to infinite. M is the only one parameter of this distribution. Mean of Poisson distribution is m. Variance of the Poisson distribution is also m, and hence its standard deviation is square root of m. So you can say that in Poisson distribution, mean and variance both are same and they are equal to m. And remember that m is equal to n into p. M equal to n into p. So all these our examples will be based on this formula. So let us move on. See, next property is Poisson distribution is always having positive skewness. In Poisson distribution, as m increases, its skewness decreases, and as m decreases, its skewness also increases. Okay. Okay. For Poisson distributions, our frequencies in starting are higher than the end. Sorry. So see, this is one of the important property. Poisson distribution is a distribution of rare events. So whenever the example is related to rare events, you can use Poisson distribution. Acha. Then sum of two independent Poisson variates is also a Poisson variate. This function is known as recurrence relation for the Poisson distribution. Now, these are the properties. We are not going through the proof of this property. This is calculation of mean and variance of the Poisson distribution, where you can use this distribution in industrial production to find proportion of defective items. This distribution can be used. This distribution is used to find error per page in any type material. In industry, whenever there are rare events, you can use Poisson distribution. So kindly remember the only one thing. that this is distribution of rare events, and whenever the events are rare, we can use Poisson distribution. In statistical quality control also, we can use this distribution. In the area of business, you can use Poisson distribution. In production management also, this distribution is used. These are some practical examples. Distribution of number of goal in football match, distribution of number of accidents occurred on a road. See, these all events are rare. Distribution of bacteria in a drop of blood, distribution of misprints per page in a book, distribution of number of defects in a radio set. This is the table to calculate various values of e raised to minus n based on the given value of n. We will use this table later on. Now, let us see how you can calculate examples of this distribution. See, this is the first example, first illustration. Illustration is 100 electric bulbs are found defective in a lot of 5,000 bulbs. We require probability that at the most 3 bulbs are defective in a box of 100 bulbs. So 100 bulbs are found defective in a lot of 5,000 bulbs. So 100 bulbs is a sample. We first require probability of getting a defective bulb. So from the 5,000 bulbs, 100 are defective. So what is probability of getting defective bulb? P is equal to 100 upon 5,000, and this will give you 0.02. Now in a box of 100 bulbs, n size of the sample will be 100, and therefore m is equal to np. np equal to 100 into 0.02, which will give you 2. So in the Poisson distribution formula, we will put value of m equal to 2. And we require probability that at the most 3 bulbs are defective. So that means that here the values of x will be minimum 0, then 1, 2, and maximum 3. At the most means maximum. At the most means ज़्यादा से ज़्यादा, વધારે માં વધારે. So this required probability will be probability Px less than or equal to 3. And this will be equal to P0 plus P1 plus P2 plus P3. If I use m equal to minus 2 here, m equal to plus 2, sorry, m equal to 2 here, this will be like P0 equal to e raised to minus 2, 2 raised to 0 divided by 0 factorial. Then P1 x equal to 1. So e raised to minus 2, m equal to 2, 2 raised to 1 and divided by 1 factorial. Then if I put x equal to 2, I will get e raised to minus 2, 2 raised to 2 divided by 2 factorial. And then e raised to minus 2, 2 raised to 3 divided by 3 factorial. So this will be e raised to minus 2 is common from all these terms. So we will take e raised to minus 2 as common factor. 2 raised to 0 will be 1. 0 factorial is also 1. So this will give you only 1. 2 raised to 1 is 2 and 1 factorial is 1. So this will be also 2. Then 2 square is 4. 4 divided by 2 factorial is 2. So 4 upon 2 is 2. Then 2 raised to 3 will be 8. 8 divided by 3 factorial. 3 factorial will be 3 into 2 into 1. So this will be 6. So 8 upon 6 will be 1.33. If we add these three terms, we will get 6.33 and e raised to minus 2 will be observed from the table. So from where I can observe this table? E raised to minus 2. So I will use this value from this table. For m equal to 2, e raised to minus 2 will be 0.1353. So using this value, 0.1353 into this 6.33 will give me the required probability 0.8924. So this is my final answer. So this is how I can calculate example related to Poisson distribution. Observe the second example. For this Poisson variable x, if probability x equal to 3 is probability of x equal to 4, then we require probability of x equal to 0. Now, we know that probability function of Poisson distribution is this. If I put x equal to 3, I will get this. If I put x equal to 4, I will get this. Now, we are given that probability of x equal to 3 is equal to probability of x equal to 4. That means this number will be equal to this number. So, e raised to minus m is on both the sides. So, we can cancel e raised to minus m from both the sides. After some simplification, I will get m cube can be cancelled with this 4. So, here I will get 4. 4 factorial, 3 factorial will be cross multiplied. What I will get? Here I am getting 1 equal to m upon 4. And from after cross multiplication, I will get m equal to 4. Now, in this example, after finding the value of m, we require probability of x equal to 0. So, for x equal to 0, in my probability function, I will get this x equal to 0 e raised to minus m raised to x means m raised to 0 and x factorial means 0 factorial. Now m equal to 4, so I will get e raised to minus 4. So answer of the example is e raised to minus 4. For this also, you can use this value also for this answer. M equal to 4 gives 0.0183. This is value of e raised to minus m for m equal to 4. So using this table, I am getting this answer. Now let us move to the next example. In this example, a person has two taxis to hire. The distribution of demand of taxis is Poisson and average demand of taxi per day is 1.5. See, average means mean of the distribution. So in this example, I will take m equal to 1.5. Now, out of 100 days, in how many days there will be no demand? No demand means zero demand. And next is he will not meet the demand. So let us solve the first question. M equal to 1.5. Now, in Poisson probability function, what I require is m equal to 1.5. So, if I put m equal to 1.5, I will get this probability function. Now, for the first question, there will be no demand of the taxi. पूछा गया है, there will be no demand. No demand means x equal to 0. So, if I put x equal to 0 here, I will get e raised to 1.5, 1.5 raised to 0 and divided by this will be 0 factorial. You know that anything raised to 0 is 1 as well as 0 factorial is also 1. So what will be the final answer? It will be e raised to minus 1.5. Now, how I will get value of e raised to minus 1.5? So for that, you require table of the Poisson distribution. Now, in examination, suppose you are not having this table of Poisson distribution, you can use this table also. Sorry. Uh, Let us move to table of the Poisson distribution. See, in this table is known as cumulative probability of Poisson distribution. This table is known as cumulative probability of the Poisson distribution. So, in this table, what I will do is I will search value of lambda or which is our m. In this table, they are denoting this by lambda, but we are denoting parameter of Poisson distribution by m. So what you have to do is you have to observe the first column of the table. You have to find out the value of 1.5 here, 1.5, and you require this corresponding number. See, against the value of 1.5, the number is 0.223. So we will use this number 0.223 in this example. So here see, the value of e raised to minus 1.5 is 0.223. So if I use this value, I will get the required probability equal to P0 equal to 0.2231. Their answer is maybe more precise because of they are using a table having 4-digit values. Now, number of days for no demand. There are we require this thing out of 100 days, in how many days there will be zero demand. So out of 100 days we have to multiply 100 with the probability that we calculated 0.223. So 100 into 0.2231 will give us 22.31. So approximate answer is 22 days. So on 22 days, this person will have no demand of the taxi. Now, the second question. Second question is he will not meet the demand. He will not meet the demand only when there are more than two customers because the taxi owner has only two taxis to hire. Two taxis to hire. So he will not complete the demand of customers if the demand of taxi is greater than 2. So in this case, we require probability of x greater than 2, which is equal to 1 minus probability of x less than or equal to 2. Here there is a printing mistake. Here that it should be less than equal to. So he will not meet the demand if this thing occurs. Now 1 minus probability of x less than or equal to 2 will be P0 plus P1 plus P2. Now using the probability function of Poisson distribution, for x equal to 0 I will get this, for x equal to 1 I will get this, for x equal to 2 I will get this. So e raised to minus 1.5 is once again common in all these three. So this is taken as a common factor. Now remaining this will be equal to 1. This will be equal to 1.5 upon 1. So 1.5, and this will be 2.25 upon 2. So that will be 1.125. Now we already observed the value of e raised to minus 1.5 from the table, which is 0.223, and this total is equal to 3.625. So this will be 1 minus 0.8087, and therefore the answer will be 0.1913. So out of 100 days, we will multiply this probability with 100. The number of days for which it is not possible to meet the demand will be 100 into the calculated probability of x greater than 2, which is 0.1913, and this will give you 19.13. So approximately 19 days. So this is how we can calculate examples of Poisson distribution. Thank you for listening. Thank you very much.